Hi, in this video I'm going to do a simple program demonstrating the B3 memories as simple relay logic. I'm going to enter a few rungs here and do a simple program. Click it there, you choose the contact you're going to use and you just drag it down, or you can click it there and just click the contact and it'll insert it. You go here, drop that there, drop an open contact there, or a close contact there, put another rung here, another rung here, and I'm going to use normally open and normally contacts, and then I'm going to load this up on the simulator, and then you will see how the contacts react. Okay, so double click, enter an I, click on input, it'll give you the first available input, enter. I have this already labeled as a stop. Enter an I there, give you the next available input, start B3:1 B3:1, enter, and you can label this run, and it ties this bit to that. That's the latching bit. This will be like the memory auxiliary contact on the contactor, and it behaves in the same manner. So here I will enter the same address as the B3:0/1, and then you could copy the address and then just insert it, copy, paste, and then just double click, backspace to get rid of that question mark, and then paste again, backspace, paste, that's it. Okay, on the outputs, I can have different outputs here, so I'll have output 0 detected, output 0 upload. These are terms that I was using on a previous program, that's why it's coming out like that. But I guess I could just leave the labels for now. Okay, so here goes, and then once you get your program on there, just click on this to verify the program, then you'll get this right here, verify has completed, no errors found, and then you're ready to go online. I have the processor already hooked up to the or uploaded to the simulator, so then I will go online. Okay, so download is, here it goes, run mode. Okay, it was giving me a little bit of discrepancy here because I had a previous program loaded up to that simulator. Okay, here it goes. So now you can bring up the input table to do this, or you could toggle it with a right click. You could toggle it here and see how this activated the B3 run memory. The run, this is an internal bit, it latched onto that, and you could disactivate the start button and it'll stay latched. So now you have the B3 run on a normally open contact, which is output 2 bit auto, and the run bit on the unload is off. The B3:1 eject medium is on the output 2, bit 2 is on, and the B3:01 on the output 2, bit 3 is off. You can check the outputs here. This is the output table, and these outputs correspond to the outputs here. This is what we have on the bottom load. That's from a previous program. Let's see, yeah, okay. So we have 2-0, 2-2 energized, 2-0, and 2-2 energized. Now I'm going to deactivate the stop or activate the stop, and it should turn everything off. Now right here, what's occurred is that the normally closed contacts have energized and have become true, because this is off, and so the normally closed contacts, that's what you get when you use these B3 memories as a relay. So when you're programming, that's one thing to consider, is that anytime you energize that stop button, whatever close contact you have on there, it's going to become energized. And these two will reverse once you energize the input 1. So I will energize the input 1, and see that's flipped over. So one of the common practices that you use when you're programming is that on the stop button, you normally program this as a normally open contact, and the stop button on the hardwire is a normally closed, and it's just the opposite of whatever you have programming. The reason being is because when you de-energize this circuit here, you will de-energize the circuit, toggle that turns off your run bit, but whatever normally closed contact you have on the program will become true, and whatever load you have on that output will become energized. So that's just one thing to keep in mind when you're using the B3 memories as logic. And that's it for this video.